Everyone's worried about AI becoming too smart to control, maybe taking your job, or making decisions about your life that you can't override. Ever wonder if the thing that saves humanity isn't some brilliant safety mechanism we invented? Maybe it's something way simpler, something AI can't code its way around. Today, I'll explain why AI's massive energy appetite might be our accidental safeguard like you're 5 years old. By the end, you'll understand whether physics just bought us time we didn't know we had, or are we still racing toward a cliff with the brakes cut? Here's the deal. Your brain runs on about 25 watts of power. That's less than a refrigerator light bulb, fueled by whatever you had for lunch. You can read, write, recognize faces, crack jokes, and feel existential dread about your mortgage, all on the energy equivalent of a dim light bulb. Now compare that to ChatGPT. Training it took over 1,000 megawatt hours of electricity. That's enough to power a small town for weeks. Running it for just 1 day takes 260 megawatt hours of power. GPT-4 required 50 gigawatt hours just to train. That's the energy of 50 million light bulbs burning for an hour. All so it could learn to write your emails and occasionally hallucinate fake legal citations. The gap between human efficiency and AI hunger isn't closing, it's getting wider. Every new model needs more power, more cooling, more infrastructure. You can't just download a superintelligence onto your laptop and hope your apartment's circuit breaker doesn't notice. These systems need data centers the size of warehouses, filled with processors that run so hot they need industrial cooling systems just to keep from melting. Experts predict that within a few years, machine learning could consume 1,000 terawatt hours annually. That's roughly 4% of all electricity produced on Earth. Not for all technology, just for AI. Now here's where it gets wild. Every expert timeline about AI development has been catastrophically wrong. Things that were supposed to take decades happened in 4 years. Capabilities that researchers thought were impossible showed up in the next model release. AI that can pass medical exams, write code, generate art, hold conversations that feel unsettlingly human. All of it came faster than predicted. The kind of faster that makes people who study this for a living start saying things like, "We might have less time than we thought." And power infrastructure moves at the speed of construction permits. Think of it like this. Imagine your gym membership suddenly required you to bench press a car. You can't just try harder. You need different equipment, a different building, maybe a reinforcement permit because the floor wasn't designed to hold a Honda Civic. AI companies can write smarter algorithms all day long, but they can't wish a new power plant into existence. Building electrical infrastructure takes years, and upgrading the grid takes even longer. You can't Amazon Prime a nuclear reactor. The physical world has a speed limit, and it's way slower than software development. That gap might be the only reason we're not already living in a science fiction novel we didn't ask to be characters in. This matters because every apocalyptic AI scenario assumes unlimited scaling. The AI recursively improves itself, suddenly 1,000 times more capable overnight. Except that assumes infinite computing resources and infinite power, which we don't have. The problem everyone's freaking out about is real and completely unsolved. We know how AI functions: neurons, layers, training data, optimization algorithms. But we don't know why it makes specific decisions. It's like knowing a car has an engine, wheels, and brakes, but not understanding why it just swerved into oncoming traffic. We can see what goes in and what comes out, but the middle part is a black box filled with billions of mathematical relationships we can't trace. Researchers call this the alignment problem. How do you make sure AI wants what we want when we can't peek inside its decision-making process? But the energy bottleneck isn't a mystery or some philosophical puzzle. It's basic physics. Energy can't be created from nothing. Running a superintelligent AI requires absurd amounts of power, and we only have so many power plants. You can't optimize your way out of the laws of nature. You can't write clever code that makes electrons move faster, or reactors produce more energy than the universe allows. You hit a hard wall made of gigawatts and grid capacity, and the fact that your data center just tripped the breaker for 3 city blocks. This isn't theoretical. Data centers are already getting rejected by utility companies who literally say, "We don't have enough electricity for your project." The energy constraint isn't a solution. It's a speed bump that might buy us a few extra years to figure out alignment before things get completely out of hand. Some researchers thought we'd have decades to solve these problems. Turns out we might have less than 10 years before AI capabilities start looking less like helpful tools and more like independent agents with goals we didn't program. But here's the weird silver lining. The thing slowing down the timeline isn't human wisdom or careful planning. It's electrical grids and power plants that take 5 years to build. It's cooling systems and infrastructure, and the boring physical constraints of reality that tech billionaires can't disrupt with an app. The real safety mechanism isn't a kill switch we build into AI. Those are way harder than they sound. The safety mechanism is what nature built into the universe itself. There's only so much power to go around, and building more takes time measured in years, not update cycles. You can't scale electricity the way you scale software. Every watt has to come from somewhere real. A turbine, a solar panel, a reactor, all of that takes space, materials, permits, construction crews, and time. The kind of time that makes venture capitalists impatient and quarterly earnings reports look disappointing. Think about what this really means. AI companies want to build systems that get exponentially smarter, each generation training the next. But that exponential growth hits a brick wall when the power requirements exceed what the grid can deliver. You can have the smartest algorithm in the world, but if you don't have enough electricity to run it, it's just expensive data. Like owning a Ferrari with no roads. We're not safe. Let's be clear about that. The alignment problem is still unsolved. We're still building systems we don't fully understand, hoping they stay helpful. But we might have bought ourselves time because reality has speed limits, and AI companies are hitting them hard. Some areas are seeing utilities tell tech companies, sorry, we don't have enough electricity for your next project. You'll have to wait 3 years for us to build more capacity. That's not a business problem, that's a physics problem. And physics doesn't negotiate. Here's what you need to understand. We're in a race between AI capabilities and AI safety. The capabilities side has been winning, with every breakthrough coming faster than expected. But the curve has to flatten somewhere. Not because we got wise, but because the power requirements become impossible to meet without massive infrastructure investment. We can't build infrastructure fast enough to keep up with the appetite of increasingly powerful models. That gap between what AI companies want to build and what the electrical grid can actually support might be the only reason we have any time left. The bottleneck isn't silicon chips or computer code. It's copper wires and power transformers. It's the unglamorous reality that electricity doesn't magically appear when you need it. Every watt has to be generated, transmitted, and cooled, and all of that requires physical infrastructure that can't be downloaded or patched. So here's where we are. AI development is outpacing our ability to control it. The systems we're building have decision-making processes we can't explain. Every expert timeline has been wrong in the too optimistic direction. But the laws of physics don't care about software updates. Energy requirements are creating natural bottlenecks, and power grids are hitting capacity limits. Building more infrastructure takes years we might desperately need. The accidental safeguard isn't human brilliance. It's the boring fact that you can't run a god-tier AI on the electrical equivalent of a cheeseburger. That gap between what's possible in software and what's possible in the physical world might be the only brake pedal we have. To recap, your brain runs on 25 watts, while AI models consume gigawatt hours. Training costs are exploding, 1,000 terawatt hours annually within a few years. Every expert timeline about AI capabilities has been wrong, with breakthroughs arriving years ahead of predictions. We can't see inside AI decision-making, even though we built the systems. But energy constraints create physical bottlenecks that software can't optimize away. Building power infrastructure takes years, not update cycles. The electrical grid might be our accidental brake pedal, buying time to solve safety problems before capabilities run too far ahead. So here's the real question. Is the power grid buying us enough time to figure out AI safety? Or are we just building a slower apocalypse that gives us more time to worry about it?